Hello there. Hi. Thank you for attending. Today I'm here to talk about immersion cooling. It's coming. It's here actually. And we're going to talk about a little project that we've been working on the last few months, where we've integrated some open compute components and members in this joint project. Just very briefly, my name's Daneil Pope. I'm CEO at Submer Technologies. We are a company based in Barcelona, Spain, and we develop immersion cooling systems. It's kind of the first building block of a subset of technology that we're developing, but our vision is to develop a system which is practical, that can be easily deployed in existing facilities, in greenfield builds, and that really helps overcome that kind of mental leap that we need to do when seeing IT equipment in fluid, right? Our company started in 2015, and we spent practically 3 years in R&D, developing our own fluid after evaluating all the stuff that was on the market. And in that process, we designed our own immersion tanks. We built a very large engineering team, which has all types of thermal, industrial, product engineers, chemical engineers, and we just landed in the US as well. So we're based in Barcelona, as I mentioned, where we have our main headquarters. That's where we manufacture the units like the one that you can see downstairs in our booth in A6. We also have our chemical lab there with a whole set of machinery that I don't really understand what it does, but we're able to measure all the types of properties that our fluid, how it behaves over time. It has its own roadmap to improve it, etc. And just recently, a couple of months ago, we also landed in the US. So we have US presence in Ashburn, Virginia, for some obvious reasons, where there's a substantial amount of data center infrastructure there. And we have some key partnerships. We are a very engineering-focused company. We take a holistic approach to supporting the customers when it comes to building engineering and getting these systems in. We have designed a technology to make it very easy to adopt and install in existing facilities, and that's why we're very supportive in the Advanced Cooling Solutions work group, where we're trying to make sure that bringing this technology in will not disrupt future plans or how facilities are being configured today. But it does go to say that it's not as easy as just dropping a tank in that facility and everything works marvelously. When you can achieve the most interesting efficiencies and densities is when you take a holistic approach and look at how the secondary cooling should perform, how do we collect that heat and reuse it, how maybe combining things with heat pumps we can pass on energy to communities that are close or industries that are close. So we like getting involved in this mess. And even if it gets really complex for us, it's quite fun. Although the product you'll see downstairs is something that's designed to be plug and play. It's a box which is essentially just needs a water feed and power feed like a dishwasher, and it does its magic. Now, we presented back in March at the Open Compute Global Summit, the SmartPodX. This machine is a immersion cooling system which accommodates both 21-inch and 19-inch hardware. It's we build it in two form factors: a smaller one, 21 OpenUs, and the 42 OpenU form factor. which essentially allows also to introduce additional redundancy in the system because we have more space. We can dissipate up to 100 kilowatts of heat with warm water loops. So if we use something like 45 degrees C water, that allows us to dissipate 100 kilowatts. We have customers that don't really care so much about the efficiency and feed chilled water to these systems, and that allows them to dissipate things that are unprecedented. But to say the truth, today it's quite challenging to find hardware that you can actually deploy in these systems. As I mentioned, we have in-house fluid engineering. We develop our own fluid. A few reasons for that, but mostly because the stuff that we found commercially on the market was, I'd say, not up to our standards. We weren't comfortable with it, and we didn't really have control over it. So controlling the full stack of the technology really allows us to do a lot of fun things. And then when it comes to the open compute application embedded into the product, we obviously had to think, how do we put bus bars in there, and how do we make things serviceable when you only have a horizontal rack to work with, right? So that's some of the challenges that I'll be briefly talking about now. The case study, moving on to the case study, so that's the spam on the company. Now we get into the interesting stuff. The case study is about a project that we ran very recently, and that some of the information is still embargoed until the official announcement comes from the European Commission. But the partnership was between Submer, a public listed multinational, European public bodies, and multiple open compute members. Specifically, the customer is the European Commission, the Joint Research Center for the European Commission. They are, for those of you who are not familiar with that name, the, let's say, R&D division of the European Commission. And they have multiple excellence centers across Europe. Specifically, we're deploying this supercomputer into their facility in Italy, in Ispra. And Airbus Defense and Space, their cybersecurity division, is essentially our technology partner who's helping us with the integration there and so on. So it's a joint project with these two pretty recognized entities, let's say. There's going back to that, there's more very relevant names that should appear there, European Commission entities that I can't mention yet, but on the news we should be able to see them very soon because this project will be announced. Going slightly into the timeline, it was a very long project. Like with any public entity, we had more than 4,200 interactions, emails, calls, etc. So a very long and painful process that started in April, over a year ago. Went through a tender process where we deployed one of our units, one of our previous models. And then just very recently, we've started deploying the production system, which all I can say now is that it's in the tens of units, and so it's in the megawatts range. These are the partners that we have been working with from a hardware perspective and integrating it into a full solution. It's been very easy and a pleasure to work with these companies. We've received a lot of support, and they are truly embracing immersion technology, which at this stage is they're on the frontier, I would say, of innovation. Now, a little bit of details about the project itself. The customer wanted to cool a substantial amount of GPU. This is a large AI machine, again related to cybersecurity. So that was one of the challenges. They had a very restricted space in a new facility that they were building to deploy this supercomputer. And not only the space was limited, but also the budget, like always. A very aggressive budget that we had to stick to, and really try and help them get the most out of each euro that they were spending. The greenfield facility has its advantages and disadvantages. In this case, truly they only had a very small area to deploy this amount of compute, and so with air-based systems, it was a substantial challenge, which really was pushing the capex up substantially. Again, it's a European body and all related with cybersecurity, so highly secure environment, and they had to be very confident that this technology was going to perform. One of the reasons why we run a pilot for quite a few months with them. Now, their challenge was that each of the nodes they wanted to cool had 8 GPUs, so it was pushing the power consumption above 2 kilowatts per node. And this in air is quite painful to deal with and expensive. In immersion cooling, and specifically in our technology where we have a forced flow of the fluid pushing, making sure that there's enough renovation of the cooler fluid through the IT, for us, we can take these numbers way higher. So we've done projects where we're deploying about 6 or 7 kilowatts per U, and it's still something that we can easily cope with. The customer was not considering open compute in any way. Actually, they weren't familiar with open compute. So one of our tasks was to help them understand how open compute could help them in this project on the CapEx and on the OpEx side of things. So that was quite a process to convince them. Being the European Commission, there was quite a lot of interest that, if possible, some of these suppliers would be European, of course. And another very nice thing of this project is that most of the heat generated by the supercomputer is actually reused by the district heating system that their facility has. So that's a very nice use case of actually having this giant supercomputer acting as a boiler. And there at the bottom we can see a comparison of 200 regular air-cooled racks. If you have the capacity of building powerful enough servers, you're able to dissipate the same amount of heat in only 20 of our larger smart pods. Now, this is quite interesting. This is considering total cost of ownership of the project, so OpEx and CapEx, because they were looking, the budget's a 4-year budget. It needs to include running the system for 4 years. And the conclusion was that with the savings that they were achieving in cooling, essentially they could obviously convert that into a more powerful machine and buy more IT hardware. So that's essentially what we did. It was a closed budget, but the more IT hardware we could get in there for that price, the happier everybody was going to be, the more powerful the machine. And immersion cooling really made a big difference there, because the savings on the simplicity of the secondary water loop and the operational savings on removing the fans from the systems that already represent about 25% of the power consumption, together with the PUE that immersion cooling delivers. And in our case, the full facility PUE for this deployment is around 1.03, which is typically where we end up when we implement dry coolers in regions where they can perform pretty well. Take into account that, as I mentioned, the water loops operate pretty warm, and that means that we can practically use dry coolers anywhere on the globe all year round. Dry coolers obviously having a substantially lower maintenance than other systems out there. The configuration of this supercomputer includes a number of SmartPods, the XL version, which is the larger tank than the one we have downstairs is the smaller one. So there's a number of those. These, I'll explain now, are able to dissipate different capacity depending on the cooling distribution units that we deploy. We deployed also a number of 2CRSI Octopus nodes. These are nodes that are designed specifically for immersion cooling. So I'll go a little bit into the details now of those nodes. The LiteOn power shelves, where we had a great collaboration with LiteOn on overcoming some of the challenges of putting power shelves into immersion cooling, because we don't get the chance to bolt them onto the bus bars, for example, or we don't get to connect the AC cables through the back of those power shelves. So these are things that we're trying to bring to the Advanced Cooling Solutions work group to try and see if down the road we can get a specification that's slightly more friendly with immersion cooling. But thankfully, the ODMs are very eager and willing in supporting the technology. And then we deployed FS fanless switches, which also helped reduce substantially the CapEx cost for that component. All to say that everything here has full warranty for immersion cooling. So the customer was completely comfortable that what he was purchasing wasn't a little experiment. It's fully warranted and supported by the hardware manufacturers. So that helped them feel comfortable with the equipment that was being deployed. Now, in our SmartPods, we can deploy one cooling distribution unit, which allows us to dissipate 50 kilowatts, or we can deploy two, which means we can either have full redundancy with two separate water feeds, or we can extend the dissipation capacity up to 100 kilowatts. This really protects the investment, meaning you can start with a system that's able to dissipate 50 kilowatts, and if at some stage you want to renew the IT equipment and you're pushing it further, you can deploy an extra cooling distribution unit into our tanks and you're able to just dissipate more. And I'm very happy to, if anybody wants to come down to the booth and get a bit of more insight on how this works and how the water loops are connected, I'm very happy to explain that to you. The servers, as mentioned, 2 CRSI nodes in this case, open compute, of course. Each of these is housing 8 GPUs, very power-hungry GPUs. We went for a 12-volt, 2-bus bar configuration, gigabyte motherboards, very good support from the Gigabyte team as well for integrating this solution and making sure that it was ready and certified for immersion cooling. Obviously, no moving parts, some very simple modifications like having all the connections on, making sure that all the connections are on one side, that we have this hoisting mechanism for when we need to extract the servers from the tanks. And obviously, totally vanity-free, very few pieces required because there's no need for managing air in these systems. So you end up with a very bare, very basic server. The savings regarding versus traditional IT equipment on the CapEx side were around 8%. So that was one of the reasons why it was quite easy to convince the customer to go down the OCP route. If already with the IT equipment they were saving this amount, and then on the OpEx side even more, it started to make them feel very comfortable. And those savings include the power shelves, which of course are something intrinsic to Open Compute. Regarding the power shelves themselves, the modifications that we had to do were around, obviously, the clips, to clip them onto a bus bar, because if we need to do maintenance and extract them, obviously we need something that's not bolted, and it's not an option to get down and swim into our tank and bolt the bus bars, bolt the power shelf onto the bus bar. There's other minor adjustments, but the front connection for the AC was another requirement, and we had to sacrifice a PSU for that. But we already have some designs where we don't need to sacrifice a PSU, and we're also working with other power shelf manufacturers that are providing more densities, and so it's quite interesting. Everyone's very eager to work in this space, and it's extending our amount of products that we can provide and offer in immersion cooling. And something that we're working on in the Advanced Cooling Solutions work group, and that we're very eager to find solutions and share some specifications there. And we're working with quite a few partners, is the safety on the bus bars, because these bus bars are lying horizontally. Obviously, anything that you drop in one of the tanks could fall on the bus bars, so that's a challenge. And it's something that we found a solution for. We will be exposing it to the community together with some of the other members, but there's work to be done. And these are some of the topics that we bring to the conversations when we get involved into the open rack and so on. So resuming, the total cost of ownership for this project on the CapEx side was reduced by more than 50% versus a traditional deployment. And that's because on the liquid cooling side of things, the build of the facility was easier. So they could use, instead of a white space, they could use something which was just simpler. The more density and future-proof investment, meaning today they can dissipate 50 kilowatts per tank and tomorrow up to 100, was also very empowering in that sense. And obviously, as mentioned on the Open Compute, on the hardware, we had a clear savings because the hardware is simply cheaper. On the OpEx side, it's mainly the PUE that's driving the savings on the OpEx. These systems with closed water loops, no water consumption, and using dry coolers are helping to bring the OpEx down substantially. And when it comes to maintenance of the systems, we see in immersion cooling a 80% reduction in hardware failure rate. And that's essentially because you don't have moving parts, the servers are in very stable temperatures, the hotspots that are generated in a bunch of servers don't really affect the rest of the servers like it happens in air. There's no particles in suspension, no dust, so the IT hardware essentially has a much longer lifespan. And what was interesting is when we mentioned to the European Commission that Open Compute was an open standard, that was something that really also generated a lot of interest, and they were very eager. That was one of the reasons that had a lot of weight, let's say. For them to support an open standard was a plus, a box they could tick. So at the end of the day, they were very happy with adopting Open Compute, and it wasn't only on the pure economical side of things, but for many other reasons. So just here briefly, by 2023, we think that 50% of the HPC deployments will be liquid cooled. It's not just us saying this. But this goes to show this is a multi-megawatt facility, which is up and running, which is used for cybersecurity, and it's immersion cooled. Thank you very much. Does anybody have any questions that I can help with? Okay, thank you.